Good morning, kiddos. Today we're going to be talking about 1.5 day 4. Okay, so today we're going to talk about things that we learned with segments and apply them to angles. Okay, so the first thing we have is congruent angles. Just like we had congruent segments, we're also going to have congruent angles. Okay, and these are two angles that have the same measure, the same number of degrees. So if we have two angles right here, and I say that this one is 30 degrees and this one is also 30 degrees, then these two are congruent because they're both 30 degrees. They have the same measure. The next thing we're going to talk about is angle bisectors. Okay, so an angle bisector is just like a segment bisector, where we take an angle and we have a third ray splitting the angle in two equal halves. And just like we had strikes with segments, like if we had a segment, we could say that these two are congruent by having little tick marks. We have something called strikes, which are little semicircles that go inside the angle to notate that these are congruent. So let's look to see if this angle has an angle bisector, okay? So we see that there's a third ray down the middle and that there are two strike marks here, so showing that both sides of this angle are 24 degrees, okay? And since both sides are congruent, this ray in the middle here cuts the angle in half or is an angle bisector. So let's name the angle bisector, okay? Remember that with rays, we start at the start point, so point Q, and then we follow the line and go through a point that it goes through. S. And then when we name rays, we have a line over top with one arrow. So the angle bisector is ray QS. Okay, this next one, even though it has three rays and we have one in the middle that could be an angle bisector, we don't have any strikes up here and we don't know the angle measures to say that they are the same. So we don't have enough information to say that this middle ray, MK, is an angle bisector, so no. And this last one, let's look at this angle. We don't have any strikes, but we do have a third ray going down the middle, and we know that both of these are 60 degrees. 60 is equal to 60, so we can draw our own strike marks in there because we know 60 is congruent to 60. 60 is equal to 60. So we know that this angle, PQS, is congruent to angle SQR because we see 60s in both of these. So first, let's name the angle bisector, this middle ray. We start at the start point, point Q, and then we follow the line and name the point that it goes through, S. Again, straight line with one arrow because it goes off forever in one direction, and we know that this has an angle bisector. Okay, so this first example, we're going to, with this first example, we are going to use this angle addition postulate that we learned yesterday. So the instructions tell us that ray QS is an angle bisector, meaning that these two sides of the angles are congruent. So I'm going to put in our strike marks. We know that they're congruent. And then that means we know that angle SQR is also 50 degrees. So step one, we have to set up. So we're going to say the measure of angle, and then side, vertex, side, PQS, plus the measure of angle SQR, side, vertex, side, SQR, is equal to the whole thing. So the measure of angle, side, vertex, side, PQR. Okay? Step two, we have to substitute in what we know. We know that PQS is 50 degrees. We know that SQR is also 50 degrees because they are congruent, because QS, the ray QS, is an angle bisector. And we don't know what the whole thing is equal to yet, so just measure of angle PQR. Okay? And step three, solve. So we're going to add these two 50s together. 50 plus 50 is 100 degrees. So the measure of angle PQR is 100 degrees. Okay, this next one has some algebra in it, so it's going to be gross. We know in the instructions it says that BD, right, BD is an angle bisector. So it means that these two things are congruent, okay? So since they are congruent, that means that they are equal. So we can set these two yucky algebra pieces equal to each other, okay? So I'm going to say that 3x plus 6 is equal to 7x minus 18, okay? I hate negative variables, so I'm going to move the smaller x. So I'm going to subtract 3x once on each side of the equal sign. Positive 3x minus 3x, those cancel, leaving us with just a positive 6 on this side. 7 minus 3 gives us 4, and that x hangs on. And then we're going to bring down that minus 18 because we haven't touched it. Okay? I want my x's alone. So let's move this 18. Since we are subtracting, the opposite operation is adding 18, once on each side of the equal sign. Subtract 18, add 18, those things cancel, and we are left with just a 4x on this side. 6 plus 18 gives us a positive 24. There's some multiplication going on between our coefficient and our variable. So to undo multiplication, we have to divide once on each side of the equal sign. Multiply 4, divide by 4, those things cancel, leaving us with a 1x that we don't have to write the 1 to 4. And then 24 divided by 4 is 6. So x is equal to 6. But we are not done. They did not want to know what x is. They want to know what the angle measure is. But since these are congruent, we can have a shortcut and only do one of them. Okay, so I'll pick the top one. You can pick whatever. So we have 3x, so we're going to plug in 6 for because we found what x is, plus 6. 3 times 6 is 18, and 18 plus 6 gives us 24 degrees. So we know that the measure of angle ABD is 24 degrees. And since these two pieces of this angle are congruent, they have the strike marks, this also means that the measure of angle DBC is also 24 degrees.